Good morning, dear students. How are you today? I hope you're fine. Today we're going to have a revision on quarter 4 for grade 5. Okay, let's start together. I have here words we can translate into numerical expressions. We have here sum, increased by, this is for addition. Difference, less than, decreased by, this is for subtraction. Less than or decreased must inverse the data. Product, multiplication. Quotient, division. Power, exponent, raised to the power exponent. Write algebraic expressions here. The sum of x and 7 equals what? Here I want to write algebraic expression. So when I say the sum of x and 7, sum means plus. So here x plus 7. A number y decreased by 14. Y decreased by 14. So here 14 minus y. 14 minus y. A number y decreased from 14, so 14 minus y. The product of a number n and 4. Product means multiply, so it's n times 4. The quotient of a number b and 8. Quotient means what? Division. So b divided 8. The sum of p raised to the 4th power. P raised to the 4th power, p power 4. The sum means plus. Sum means plus. Plus what? 9 times. It's easy. 9 multiply 9 times. A number q. A number is called here q. So here the sum of means plus. Okay. P raised to 4th power. So it's called here p power 4. And here 9 times the number q. 9 times q. Here y less than x. Then it's y. Here less than x. Y less than x. X minus y. The product of a number c and 7. Product of number c and 7. So c times 7. Divided by 3. Divided 3. Here I should write here. You write here divided 3. 7 less than the product of a number c and 5. The product of a number c and 5, this means what? C times 5. All minus 7. All less than 7. All 7 less than the product. 7 here less than the product of c times 5. The sum of a number x and 7. It's easy. X plus 7. The sum of x and 7. Divided. The answer of this divided by 20. The difference of, okay, here we are having minus x raised to the 5th power, x power 5, and 12, and here 12. Okay, here 4 times a number, 4 times n times a number, minus 6 decreased by 6. Here, if I have here the algebraic expression and I want to rewrite them. Okay, I have here the product of 2 and n, 2 and a number, the product of 2 and a number, divided by 5. 7 less than a number, 7 here is less than n, a number. Here I have the quotient of 4 and e. Quotient means divided, 4 divided e. Here I have 6 times, open bracket, I have here the sum of 9 and the number. Moving to the coordinate grid ordered pairs. Coordinate grid ordered pairs. I have here, do you remember the coordinate grid? I have here the coordinate plane. I have here the y-axis and the x-axis and y-axis, and I have here the origin as you see here. Okay, tell what point is located at each ordered pair. 3, 1. Okay, I go here 3 in the x-axis, I go 3, then up 1, then up 1. So it's here the F letter. Number 2, 7 and 8. 7 in the x-axis, and then I go up 8 until I reach here from here opposite to the y-axis, here 8. So it's 7, 8, it's letter H. 1 and 4, 1 on x-axis and 4 here until I get to 4 here. It's the letter what? It's the point here, M. And then 5 and 0, 5 and 0. So we're not going up, we are here on the x-axis, so it's R. Okay, write the ordered pair for each given point. I have here point A. I go here on the x-axis until I get here to the point of A on x-axis. It's 8. Then go up until I reach here on the y-axis. It's 7. So it's 8 and 7. So the ordered pairs here are 8 and 7. Okay, and so on. We want here to move to evaluate expressions. Here, evaluate expressions. 2y, 2 open bracket, y plus 6 all over 3. Okay, evaluate the following expressions for y negative 3. When you put here negative 3 plus 8 plus 6 all divided 3. Do you remember the lesson of evaluation of expressions, what we should do? Do you remember here? We have PEMDAS. Do you remember PEMDAS? The abbreviations for parentheses, then exponent for E, PEM multiplication for M, the division for D, A addition, then S for subtraction. So here I began evaluating, I began here solving the numbers between brackets. Here between brackets, y plus 6. Negative 3 plus 6 equal 3. Then PEMDAS, I don't have here exponent, so I'm not going to take exponent. After this, PEM multiplication, here 3 times 2 equals 6. Then after multiplication division, here I have 6 divided 3 will give me 2. When I follow the steps of PEMDAS, you can write PEMDAS and then write the words for the abbreviations and then solve my question easily. So I have here negative 2 bracket y power 2 close the bracket. So here it's what I have here, PEMDAS parentheses, so I'm solving the parentheses first. 3 negative 3 power 2 means what? Negative 3 times negative 3 will give you 9. Negative times negative will give you positive, so it's 9. 9 times negative 2 will give you negative 18. Okay, here after this, if he gives you two here values x and c, x equals negative 2 and c equals 8. So here negative 2 open bracket, here I have x for what? Negative 2. So I'm going to write here negative 2 plus 8. Okay, negative 2 plus 8 equals what? Negative 2 plus 8, 6. 6 times negative 2, negative 12. Okay, so here I substitute or put instead x, I put negative 2, and I put instead c, 8. Moving to the in and out boxes. Do you remember here? I have here in and out. Here in and the rule. It's important to know the rule to solve these kinds of problems. So in here 6 and the out here 10. Why? Because the rule here is to add, is given here is to add 4 each time. So here 6 plus 4, 10, 9 plus 4, 13, 15 plus 4, 19, and here he wants me to find here this one, the red one. So 22, here which number plus 4 gives you 22? So I'm going to subtract 22 minus 4. Subtract 4 from 22, that gives you here 18. In and out, here here he wants me to find the rule here. Okay, 5 okay gives me out 2. What did I do to 5 to give you 2? 7. Okay, and here what should I do? Here I subtract from 5 3 to give me 2. So my rule here is subtract 3. 7 minus 3 4. Here the red, he wants me to find the red. So what minus 3 gives you 9? I will add the inverse, I will add the opposite, I will add 3 to 9, so it gives me 12. Here in this one I am adding, the rule is to add 5. 9 to 14. Okay, what happened to 9 to 14? Okay, 9 plus 5 gives you 14 every time I add 5. Okay, then going to in and out boxes. Okay, according to we have here capacity. Do you remember? Complete the tables below and answer the questions that follow. Gallons, quarts. 1 gallon equal 4 quarts. Okay, 2 gallons equal 8 quarts. Here the rule is what? To multiply by 4 each time. 1 times 4 4, 2 times 4 8, 5 times 4 20, 7 times 4 28. So each time I multiply by 4. Here pints, here gallons. Okay, 8 pints 1 gallon. 16 pints 2 gallons. What's the rule here? Divide by 8. 8 divided by 8 gives you 1. 16 divided by 8 gives you 2. 32 divided by 8 equals 4, and so on. When I want to here answer the questions, how many quarts are in 7 gallons? 7 gallons 28. I here multiplied 7 by 4, it gives me 28. How many pints are in 1 gallon? How many pints, as you see here in the table? 8 pints. How many gallons are in 48 pints? 48 pints, I have here 6. If I don't have here this, I know that 1 gallon contains 8 pints. When I convert from a larger unit to a smaller unit, what should I do? Do you remember? Yeah, I can hear you. I multiply. When I convert from a smaller unit to larger unit, what should I do? I divide. Don't forget that. Converting liters and milliliters. Here complete the tables below and answer the questions also. This is the same kind of questions here. 1 liter equals 1000 here milliliters. So every time I multiply by 1000 milliliters here for liters, I do what? Okay, here I divide by the inverse, the opposite. Okay, from liter to milliliter, so I'm going to multiply by 1000. And here from milliliter, the smaller unit, to the larger unit, I divide by 1000. How many liters are in 5000 milliliters? Okay, from how many liters in 5000 liters, what should I do here? Here, what should I do? 5000, search in the table. 5000 here, how many liters? 5. Okay, I divide. Here I'm converting from the smaller unit to the larger unit. Do you remember the smaller unit can't multiply ever? So we're going to divide this by 1000, by their unit of conversion. Okay, so measuring capacity. 1 gallon equal 4 quarts equal 8 pints equal 16 cups. Do you remember? 1 gallon equal 4 quarts. 1 quart equal 2 pints. 1 pint equal 2 cups. Okay, here I have 2 gallons equal how many pints? If I know that 1 gallon equals, I have here 1 gallon equals how many pints? 1 gallon 8 pints. So 2 gallons will be 8 times 2. Okay, I have here 4 gallons equal how many quarts? If 1 gallon, I know that it's 4 quarts. 1 gallon times 4. Here 4 times 4 gives me 60. Here circle the greater amount for each pair. The greater amount. Okay, how can I do it? 4 quarts or 2 gallons? If I know that 1 gallon equal 4 quarts, so 2 gallons will be 8 quarts. So 2 gallons is definitely the greater amount here. If I have here 20 quarts or 4 gallons, I said that 4 gallons equal how many? 4 gallons, how many quarts? for gallons equals 16 quarts. 16 quarts are greater or 20 quarts? 20 quarts, of course. The important thing when I compare between two units here, I have to make the units the same kind of unit. I want to make them gallons or quarts. You have to convert the unit here to the same unit. You have to get here the same kind of units, gallons or quarts. Here I have cups or pints. Here I have pints or quarts. Quadrilaterals. Do you remember quadrilaterals? The geometry here we have covered this before. Now in the revision we will wrapping this up. So quadrilaterals are polygons that have 4 sides and 4 angles. Do you remember quadrilaterals? Quad, do you remember quad? It's 4 angles, or 4 here, or 4 sides. In the square, what are the attributes or the features of the square? All sides are equal in length, and I have 4 right angles inside. Each two opposite angles are parallel. In the rectangle, I have here a side longer than the other, so I have here each two opposite sides are parallel and equal in length, and they have here right angles, 4 right angles, the small pink squares inside. In the parallelogram, I have here each two opposite sides are parallel. Each two opposite sides are parallel in the parallelogram. In the rhombus, two pairs of parallel sides, each two opposite sides are parallel, all equal sides in length. All sides are equal in length, and the opposite sides are equal. The opposite angles are equal. Trapezoid, only one pair of parallel sides. Don't forget, this word is very famous for the trapezoid. Only one pair of parallel sides, just only one pair. Do you remember pair? Like pair of gloves, or pair of socks. Here pair means 2. I have here only 2 parallel lines, or only one pair of parallel sides. Do you remember parallel? This is what does it mean, parallel? This line parallel to this line means that they go in the same 2 directions. If they go, and the distance between this point and this point is equal to the same here from this point to this point. This is parallel, and the 2 lines goes in different in here. They never intersect. If they are extended forever, they never intersect. Okay, like the railway for the train. Okay, here write the name of each quadrilateral. What is this? It's the rhombus, and here it's a trapezoid, and here it's a square. The difference between the square and the rhombus is important. The rhombus, all sides are equal in length, and they may have right angles here and maybe not right angles. But in the square, all sides are equal in length, but it's a must that it contains here 4 right angles. It's a trapezoid because we have here only one pair of parallel sides, and it's a quadrilateral too. Parallelogram, each two opposite sides are parallel, so this is a parallelogram. This is a rectangle here. This is a rectangle. Each two opposite sides are parallel and equal in length. It has 4 right angles inside. How can you tell the difference between parallelogram and a trapezoid? Good question here. A parallelogram has 2 pairs of parallel sides, as I told you now, while a trapezoid has just only one pair of parallel sides. As you see here, we have this side is parallel to this side, but this side it's not parallel to this side, the opposite side. Okay, how can you tell the difference between square and rhombus? We have mentioned this before. Triangles, I can classify my triangles according to their side lengths. If I have 3 sides are equal in length, so it's called in math equilateral triangle. If I have just 2 sides are equal in length, as you see in this triangle 6 and 6, so it's isosceles triangle. It's called what isosceles triangle. In this triangle, all sides are different in length. No sides have the same length, so it's called scalene, the crazy one, scalene. So here, for example, he asks me to name each triangle by the length of each side. 3, 5, 3, so I have two sides are equal in length, so it's isosceles. 14, 9, 8, they are all different, so they are scalene. Okay, here I have 24, 24, 24, all sides are in the same length, so it's equilateral. Okay, measuring angles, we can classify triangles according to the measure of their angles. Here I have, do you remember with me the acute angle? The acute angle is an angle less than 90 degree, and I have told you to remember the acute angle like an acute baby is small, so this angle is a small angle or less than 90 degree. And this is a right angle, it stands right here, so it's 90 degree, exactly equal 90 degree, right? It's called right angle. And here it's an obtuse angle, it's greater than 90 degree, it's greater than 90 degree and less than 180 degree. This is an acute triangle, it has 3 acute angles inside. This is a right angle triangle, so it's called the right angle triangle, perpendicular, one perpendicular here. Can you see this? Yeah, it's 90 degree. I have here a right angle and 2 acute angles. An obtuse triangle has one obtuse angle here, as you see, angle PQR, or I can say RQP, or I can say angle Q. So this is an obtuse angle and the 2 other angles are acute. When I say here, identify each type of triangle, acute, right, or obtuse. Here I have one obtuse angle here, as you see by your eyes, so this is obtuse, it's larger than 90 degree. Okay, and this is acute triangle. Why? Because all three angles inside are acute, are less than 90 degrees, so it's acute triangle. And this is a right triangle because here I have one right angle, so it's called right triangle. Moving to the volume of rectangular prism. Moving to the volume of prisms here. Do you remember the volume? Okay, to find the volume of a rectangular prism, multiply the length by the width by the height. So I have here 3 dimensions. Okay, 3 dimensions. So do you remember the 3D shapes that have the 3 dimensions, length, width, and height? So I have here volume equals length times width times height. So volume equals 3 times 5 times the height, here 12. So 3 length and 5 width and height, 12. So the answer will be 100. Do you remember cubic centimeter? Why cubic centimeter? Do you remember when we have taken the volume of rectangular prisms by using the models, okay, on the online sessions? So the inside there were some cubes here, and we were counting the cubes of each layer. Do you remember? Okay, so it's called and we have 3 dimensions. So here it's called here what? Cubic centimeter, power 3 here. Here calculate the volume of each rectangular prism. Be sure to include its units in your answer. Of course, units here millimeter. So I'm going to write what? Millimeter, power 3, or cubic millimeter, because here we have 3 dimensions. And do you remember when it's here it was divided into cubes, and we were calculating this by adding all the cubes, and after this we were multiplying by the number of layers. Do you remember? So here the volume is 1 times 4 times 2 length times width times height. It gives you here 8 millimeter, cubic millimeter. And here the volume, I multiplied the same length times width times height, so it gives me here 384. And here 3 times 3 times 3, it gives you here in the cube, it gives you 27 cubic kilometers. Okay, moving to the other worksheet, the histogram. Do you remember the histogram? Below show the number of texts students sent each day. Here the number of texts, and here the students, here for x-axis and here for y-axis. Okay, it's easy. Most students sent between what and what texts? most students. Where are here the most students texts here? As you see from the histogram, the most, it must be the highest bar here. So here from 8 to 10, this is from 8 to 10. Okay, how many students sent 8 and 10 texts? 8 and 10 texts. If I look here at my histogram, I go up from 8 to 10. This is the bar of from 8 to 10. Go up until I reach and look at the y-axis. It's 5 here, so I will write the answer 5. How many students are represented in the histogram? Here I have the students in the histogram. So I'm going to do what? I'm going to add the number of students. I have here 1, this 1, and then after this I have 3. So 1 plus 3 equals 4. Then I have 4. So 4 plus 4, 8. Then I have here, if I go up here and look here, I have here what? I have 5. Then 5 plus 8 will, so here again 1 plus 3, 4. 4 plus 4, 8. 8 plus 4, 12. This is also 4. So now, okay, we have reached 12. 12 plus here 5. Can you see here 5? So it will be 17. I'm adding here the students from my histogram. This indicates 1 student, and from 2 to 4 it indicates 3 students. From 4 to 6 it indicates 4 students. So I'm adding the number of students from what? From the histogram. Okay, dear students. Now number 4. If a student sent 2 texts, which bar would they be added to? Again, if a student sent 2 texts, okay, we're here from 2, starting from 2, from the graph, from text here in on the x-axis here, from 2, from which bar? Bar 2. This is bar 2 because bar 2 indicates from 2 to 4. It's easy, my dear students. Here I have in the histogram below, show the quantity of chocolate pieces per bag of trail mix. So I have here the bags and the chocolate pieces. Okay, from 0 to 19 I have 3, from 20 to 39 I have here 7, and so on. Most bags had between what and what pieces of chocolate? Most bags. Okay, most bags here I look for the highest bar, which is from 60 to 79. So this is the highest bar. It's from 60 to 79. Okay, how many here bags? How many bags can you see? 8 bags. So how many bags had between 60 and 79? We have just answered this. 8 bags. How many bags of trail mix are represented in this histogram? How many bags here? Okay, again, what should I do? I will add all the bags here from the histogram. Here I have 3 plus 7, 10, plus 5, 15, plus 8, 23, plus 1, 24 bags. I'm here adding all the number of bags represented in the histogram. It's very easy, right? Here, if a bag had 59 pieces of chocolate in it, which bar would it be added to? 59. So I'm looking here on my graph. Okay, 59 from 40 to 59 in this one. So it's number 3, bar number 3. Okay, here find the volume of each figure in units cubic. Here I have here 1, 2 times 3, 1, 2, 3. So here 2 times 3. Volume, okay, of prisms by models. Here 2 times 3 equals 6. How many layers do I have here? 1, 2, 3, 4, 5. So the volume 6 times the number of layers 5 will give me 30 cubic units. I have here also classifying polygons. I have here a triangle polygons are the closed figures with straight sides without any intersecting sides, and they are closed, okay, not opened. Triangles, polygons with 3 sides, 3 angles, 3 vertices. Quadrilaterals, polygons with 4 sides, 4 angles, and 4 vertices. Pentagon, 5 sides, 5 angles, 5 vertices. Hexagon, okay, remember hexagon, 6 sides, 6 angles, 6 vertices. Octagon, polygons that have 8 sides, 8 angles, 8 vertices. I have here the triangle, as I told you, acute, right angle, obtuse triangle. I have acute triangle, right triangle, obtuse triangle. I have here the quadrilaterals, trapezoids, parallelogram. I have right trapezoids and trapezoids. So I have here trapezoids and parallelograms. Okay, here the parallelograms, okay, forms of parallelograms here: rectangle, I have here squares and rhombus. Okay, do you remember? And we have mentioned the properties or the features of each of them. Okay, here I have the 3D figures. Do you remember the 3D figures? A polyhedron is a 3D solid figured with flat surfaces, and solid figures with curved surfaces are non-polyhedrons. The polyhedrons with flat surfaces, solid figures with curved, are non-polyhedrons. I have here sphere, solid with no base and a point exactly in the center. It has no edges and no vertices. Prisms here, solid with 2 congruent parallel bases, okay, here, which are polygons, and it has at least 3 faces that are rectangles. A prism here can be named by the type of its base. Cylinder, solid with 2 circular bases, has no vertices and no edges. I have here a cone, solid with only one base, one vertex, and its base in the shape of a circle. I have here a pyramid, solid with a base which is a polygon. It has at least 3 faces that are triangles. Okay, a pyramid can be named by the type of its base. I have here a squared pyramid, and it can be also a triangular pyramid. I have here a cube. This is a cube, and this, or I can say it's a rectangular prism here, and it has 6 faces, 2 edges, 8 vertices, and this is a rectangular or square pyramid here. So, and this is a rectangular prism. Remember that what's the product of a number, and here I have a decimal. So here 9 times 0.05, I multiply 9 times 5 equals 45. I have here 2 decimal places, so I'm going to have here 2 decimal places after 45. Okay, going 2 decimal places and then put the decimal point and then 0. And here what's the product of 4.7 times 2? I first multiply 47 times 2 will give me 94, and then see how many decimal places, 1, and here 1, so I'm going to have 2 decimal places here, then put the decimal point, then 0. I have here a cyclist ride 14.3 kilometers in an hour. How many kilometers does he ride in? He rides in 1.5 hours. I do what here? 14.3 times 1.5 hours, so it will give me now 21.45 hours. Here I have 2 decimal places. After I here multiplied the 2 numbers, I ignored the decimal points and multiplied them. Then I have here 2 decimal places, then I move to the left 2 decimal places. By that we have covered the revision. Study well from the YouTube presentation and from the PowerPoint presentations. If you have any question, please don't hesitate to send me on Google Classroom. Thank you, my dear students.